Hello all, welcome to our channel. I am Nomsri and my friend Srija of 2nd CSCA. Our topic is RAID, Redundant Array of Independent Disk, under the guidance of Dr. M. Prasad, PhD, Associate Professor, Department of CSC, SWEC Autonomous, Bhimavaram. In this video, we will see definition of RAID, working of RAID, RAID controller, RAID levels, and advantages and disadvantages of RAID. The concept of RAID is introduced for data protection. Cloud computing is also derived from RAID. When magnetic disk gets corrupted or head crash occurs or some virus attacked and data gets hacked, it all results in data loss. Then our only solution of data recovery is through maintaining backup. But what can be the backup problems? When you copy files, data inconsistency occurs as to confusion arises as there will be no relation between original and copy file, no synchronization, and as to know which file is the latest in update. So in order to provide a better way, RAID is introduced. RAID stands for Redundant Array of Independent Disk. To protect the data in case of a drive failure, RAID provides a way of storing the same data in different places on multiple hard disks or HDDs. Even though there are different RAID levels, all does not have the goal of providing redundancy. RAID improves performance by placing data on multiple disks and allowing input and output operations to overlap in a balanced way. Because various disks increase the mean time between failures, MTBF, storing data redundantly also increases fault tolerance. A RAID controller is a device used to manage hard disk drives in a storage array. It can be used as a level of abstraction between the OS and physical disk. In case of a crash, using a RAID controller helps to protect the data, which improves performance. In case of a hardware-based RAID product, a physical controller manages the entire array. The controller can be designed to support drive formats. When coming to software-based RAID, the controller uses the resources of the hardware system, such as the central processor and memory. Coming to firmware-based RAID controller, chips are located on the motherboard and all the operations are performed by the CPU, similar to the software-based RAID. Our next concept is RAID levels. RAID devices uses different versions called levels. Before jumping into these levels, we need to know about two topics. They are stripping and mirroring. Mirroring is nothing but a disk copy, whereas stripping means storing files in continuous cylindrical fashion. For suppose my drive consists of 4 disks and my file is divided into 4 blocks. Instead of storing all the file in one disk, I am placing my file in 4 disks. For suppose if we lost a disk, only 25% of data is lost instead of 100%. That is called stripping. Now coming into the RAID 0 level, which is called non-redundant stripping. This configuration has stripping concept but no redundancy of data. That means all the disk presents are original and there will be no copies of data. This offers best performance but it does not provide fault tolerance. The next level is RAID 1, which is also known as disk mirroring. For suppose if there are n original disk, then we have to maintain n mirrored disk. In this process, the maintenance of disk is increased, which results in more cost. This configuration consists of at least 2 drives that duplicate the storage of data. So in this level, there is no concept of stripping. Read performance is improved as either disk can be read at the same time. But write performance is the same as for single disk storage. As you can see in this picture, the disk 1 contains A1, A2, A3, A4 and the duplication of disk is mirroring, which the disk 2 contains same A1, A2, A3, A4. This is called RAID 1. Next is RAID 2, which is a bit level stripping with dedicated parity. In this, error management course is introduced, which is parity bit. Parity bit is used for error correction. In RAID 2, the error of the data is checked at every bit level. For suppose if there are n disks, then n-1 parity disk will be there. As you can see in the picture, there are 3 original disks and 3-1, that is 2 parity disks are there. Using this, the cost is certainly reduced, but it is complex and not commonly used as we use 2 disks in this technique. One is for storing bits and another one for storing error code correction. The next is RAID 3, which is byte level stripping with dedicated parity. Byte level stripping along with parity is used at this level. It uses only one extra disk for storing all the parity information. For suppose in case any drive gets failed, then the parity restores the failed disk. Hence there will be no data loss. But in case if the parity is failed, then there will be no fault tolerance and we cannot restore the data in case of any drive failure. If you see in the RAID 2, we maintain n-1 parity disk and here we only maintain one disk for all the parity information. The next is RAID 4, which is block level stripping with dedicated parity. Block level stripping along with parity is used at this level. It uses an extra disk for storing all the parity information. For suppose if any drive gets failed, then the parity restores the failed drive. Then there will be no data loss. But in case if the parity is failed, then we cannot recover any data and our data is lost. Here, data or files may be distributed among multiple or independently operating devices. This helps in parallel input or output request performance. As you can see in the picture, there are 3 disks and we maintain only one disk for storing all the parity information. This is called RAID 4. Coming to the next level, RAID 5, stripping with parity. Level 5 uses block stripping. But here the major difference is that the parity is distributed among several hard drives as shown in the diagram. It requires at least 3 drives. So in case one hard drive fails to store, the other remaining hard drives can help in restoring the failed hard drive. This level 5 can handle one disk failure. The advantage is that this level provides fast performance. But the disadvantage is that the storage space could be utilized only up to 75%. Means one entire hard disk is to be kept for storing the different parity information. At this particular level, it cannot handle 2 disk failures. It strips data across multiple drives to increase performance. In this level, the array's storage capacity is reduced by one disk. And it also adds the aspect of redundancy by distributing parity information across the disk. As you can see in the diagram, each disk contains one parity information. This is RAID 5. The next is RAID 6, which is block level stripping with 2 parity bits. RAID level 6 is the enhanced version of RAID level 5. We are using parity bits, but we are using double parity bits and they are distributed among several hard disks. So this particular level helps to restore failure of 2 hard drives successfully, which was not possible in the RAID level 5. So this RAID level 6 is mostly utilized in big companies such as Google and Facebook, where high availability of data is required. In this, you need 4 disk drives for this level. A pair of independent parities are generated and stored on multiple disks at this level. So this is called RAID 6. As you can see in the diagram, each disk contains 2 parities, which is double parity. The next ones we are seeing are called hybrid RAIDs, which makes use of more than one RAID level nested one after the other to fulfill specific requirements. RAID 10 is one of the hybrid RAID, which is also called mirror stripped. This level combines RAID 1 and RAID 0 in a single system. This offers high performance than RAID 1, but also the cost is much higher. This is a nested or hybrid RAID configuration. It provides security by mirroring all data on secondary drives while using the concept of stripping across each set of drives, which improves the data transfer speed. As you can see in the diagram, both the mirroring and stripping concepts are applied. The disk 1 is mirrored and disk 2 and disk 3 mirrored, which is disk 4. These two are combined, which is RAID 10. The next hybrid RAID is RAID 01, which is RAID 0 plus 1, that is similar to RAID 1 plus 0, except the data organization method is slightly different. Rather than creating a mirror and then striping it, RAID 0 plus 1 creates a stripe set and then mirrors the stripe set. As you can see in the diagram, Disk 1 and disk 2 are striped set and these are mirrored, that is disk 3 and disk 4. This is called RAID 01. Now the last concept is advantages and disadvantages of RAID. Let us see the advantages of RAID. The first one is improved performance. By using stripping techniques, we can enhance data read and write speeds by distributing data across multiple disks. The next advantage is data redundancy and fault tolerance. For suppose in the event of a disk failure, by using parity information, the data can be reconstructed and ensuring that the data availability and protection against data loss. And the next advantage is increased mean time between failures, MTBF. The RAID can improve MTBF by using multiple disks to store the data. In case of failure of a single disk does not lead to the data loss or system downtime, as the RAID array continues to operate using the remaining functional disk. The next advantage is data protection and high availability. RAID configurations with data redundancy with like RAID 1, RAID 10, RAID 5, RAID 6, RAID 50860 offers high availability, ensuring that critical data remains accessible even during disk failures or maintenance operations. The next advantage is cost effectiveness. It provides an economical solution for achieving data redundancy and improved performance. RAID can be implemented using a combination of standard hard drives or solid state drives, allowing the users to balance cost and performance based on their needs. The next advantage is scalability. Many RAID configurations such as RAID 0, RAID 5, RAID 50, RAID 6 and RAID 60 allows for the expansion of storage capacity by adding more disk to the array. This is the advantages of RAID. Now let us see the disadvantages of RAID. Nested RAID levels like RAID 01 or RAID 10 are more expensive to implement than traditional RAID levels like RAID 0 to RAID 6 because they require many disks. The cost per gigabyte of storage devices is higher for RAID because many of the drives are used for redundancy. When a drive fails, the probability that another drive in the array will also fail soon arises, which would likely result in the data loss. Some RAID levels such as RAID 1 and 5 can only sustain a single drive failure. RAID arrays are in a vulnerable state until a failed drive is replaced with a new driver that is populated with the data. When RAID was implemented, it takes a lot longer to rebuild failed drives because drives have much more greater capacity. These are the disadvantages of the RAIDs. Thank you.